Hey everyone, welcome back. So today we're gonna level up your algebra game. You know that feeling when you see something like x cubed plus 27 and your brain kind of just freezes for a second? Well, if that's you, you've come to the right place. We're about to make that a thing of the past. Let's get into it.
Okay, so before we jump into the new stuff, let's just remember what we already know. You've totally got this difference of squares thing down, right? Good, because that skill is actually the perfect springboard for what we're tackling today.
So, check this out. On the left, there's our old buddy, a squared minus b squared. We know that one. It breaks down nice and neat into a minus b, a plus b. But what about the one on the right? That's the mystery we're solving today. What's the pattern for a cubed plus b cubed?
So yeah, how do we factor cubes? Is there some secret formula or a trick to it? You bet there is, and it works every single time.
So let's talk about our new tools. We're going to look at the formulas for cubes.
Okay, here they are, the two big formulas you need. Now, take a look at the pattern here. For both the sum and the difference of cubes, the answer is always a binomial, that first little two-term part, times a trinomial, that bigger three-term part. The only thing that can get a little messy is remembering the signs, the pluses and minuses. But don't you worry, I've got a super simple trick for that.
And here it is, your new best friend for this stuff, soap. And no, I'm not talking about washing your hands, although that's a good idea too. This is a little acronym, a memory trick that's going to make sure you get the signs right 100% of the time. It's a game changer. So how does SOAP work? It's easy. The S stands for same. Your first sign is the same as the one in the problem. The O stands for opposite. The next sign is the opposite of the one in the problem. And the AP, that's for always positive. The last sign is always a plus. So remember, same, opposite, always positive. SOAP. That's it.
All right, theory is great, but let's be real, the best way to learn this is to just do it. So let's dive into some examples and put this SOAP formula to work.
Okay, let's start with a basic one. We're going to factor x cubed plus 27.
First things first, every single time you got to figure out what your a and your b are. So what do you cube to get x cubed? Well, that's just x. And what do you cube to get 27? Let's see, 3 times 3 is 9, times 3 is 27. There it is. So our a is x and our b is 3.
Okay, now we just plug a and b into the formula using SOAP. The original problem was a plus, right? So our signs will be same, which is plus, opposite, which is minus, and always positive, which is plus. Boom, you just follow the pattern and you get the answer. X plus 3 times x squared minus 3x plus 9.
All right, you ready to level up? Let's try one with some numbers out front, some coefficients. We're going to factor 8y cubed minus 125. This time, it's a difference of cubes.
The process is exactly the same. First, find a and b. What do we cube to get 8y cubed? Well, the cube root of 8 is 2, and the cube root of y cubed is y. So our a is 2y. And what's the cube root of 125? That's 5. So b is 5.
Time to build the answer. Remember SOAP. The original problem was a minus, so our signs are same, minus, opposite, plus, and always positive, plus. Now be careful with this next part. The formula has an a squared in it. Our a is 2y. So what's 2y squared? It's not 2y squared. It's 2y times 2y, which gives us 4y squared. That is a super important detail to get right.
Okay, here's a curveball for you. What about 2x cubed plus 54? At first glance, you might think, wait a minute, 2 isn't a perfect cube, and neither is 54. Are we stuck?
Nope. This is where the #1 golden rule of all factoring comes in. Before you do anything else, you have to look for a greatest common factor, a GCF. And here, both 2 and 54 can be divided by 2. So let's pull that 2 out front. And what are we left with inside the parentheses? X cubed plus 27. Hey, we've seen that one before. Exactly. We just factor the part in the parentheses just like we did in the first example. The only difference is we have to remember to keep that GCF, that 2, hanging out in front of our final answer. So the whole thing becomes 2 times x plus 3 times x squared minus 3x plus 9.
Okay, you've got the basics down. Now I want to give you a heads up on the most common mistakes people make with these. Let's talk about some common factoring traps so you can avoid them.
Okay, trap number 1, we actually just talked about this. When your a is something like 2y, please remember to square the whole thing. The mistake is just writing 2y squared. No! You have to do 2y times 2y, which is 4y squared. You got to square the number and the letter.
And the other big mistake? Confusing cubes with squares. I know it's tempting to try and factor it into two binomials like you do with squares, but it just doesn't work that way. For cubes, the answer is always a binomial times a trinomial. Got it?
Okay, so let's answer the big question. Why does any of this even matter? Like, where are you ever going to use this in the real world? Well, let's take a quick look.
So just think about volume, Length times width times height. It's all about cubes. In engineering, architecture, design, they use formulas with cubed variables all the time. And being able to factor an expression that represents volume can actually help you figure out the real dimensions of an object.
And really, here's the bottom line. This whole thing is just a massive shortcut. You might have seen problems like this before when you were doing long division with polynomials. You could still do it that way, but why would you? The formula gets you the answer instantly. It's all about working smarter, not harder.
And just like that, the mystery is solved. You now know how to factor the sum and difference of cubes. You've got the formulas, you've got your secret weapon, SOAP, to nail the signs, and you know what traps to look out for. Seriously, you've just unlocked a huge pattern in algebra. So, now that you have this new tool, what problems are you going to solve next?